Welcome everyone to another Chem 1 lesson with Mr. Swank. Today is Tuesday, May 5th. So happy Cinco de Mayo! What are we talking about today? Well, we are talking about what are significant figures. We defined those yesterday, so today we're going to go a little bit more in depth with that. But first, as always, it's time for a joke. The best part of the day. I dreamt I was a muffler last night. It was weird, but I woke up exhausted. It's good, right? It's good. Doesn't this help? Doesn't this help make everything better? Probably not, and I'm sorry. Today's objective is we're going to identify significant figures in measurements. So let's just review a little bit yesterday what significant figures are. So significant figures are all the digits in a measurement that are absolutely known plus an estimated final digit. It keeps the accuracy and precision. And remember, this is really down to the measurement device you're using. You want to use something with as many markings on it as possible because that will give you the greatest number of significant figures. The more sig figs, the more accuracy, the more precision. But remember, while this does help to eliminate error, significant does not necessarily mean important. Digits that are not sig figs are still important. All digits in a measurement are important. Okay? Keep that in mind. So the rules for what counts as a sig fig in a measurement and what doesn't. So let's say you're presented with a measurement. How do you know what is a significant figure and what isn't? Well, there's 5 rules to consider. Rule number 1, every non-zero digit in a measurement is significant. So if you're looking at a measurement, if there's a digit in there that's not zero, it is significant. So let's look at some examples here. 24.7 meters, 210 liters, and 0.743 kilograms. So if we look at that, in our first measurement here, 2, 4, 7, we've got 3 digits. Based on rule 1, how many of them are significant? Well, every non-zero digit in a measurement is significant. 2, 4, and 7 aren't zeros, so all 3 of these figures are significant. Second measurement here, 210. 2, 1, 0. The 2 and the 1 aren't zeros. These 2 digits are significant. So this measurement, based on rule 1, has 2 significant figures. And the last one, 0.743 kilograms. The 7, the 4, and the 3 are non-zeros. That's 3 digits that are significant. That means this measurement has 3 significant figures based on rule 1. Okay? It's pretty simple. Any digit in a measurement that isn't a zero is significant. Well, if every non-zero digit is significant, then what are the other 4 rules? Well, they're all about when zeros are significant and when they are not. Rule number 2, zeros between significant figures are significant. I call this one the sandwich rule because it's basically you have a sig fig here and a sig fig here, and in between are all these zeros. Well, if those zeros are sandwiched in between 2 sig figs, they count. So let's take a look. 304 grams, 2.056 meters, and 2004 milliliters. Our first one here. So how many significant figures are there in this measurement? Well, remember, rule 1, every non-zero digit is significant. That means the 3 and the 4 are significant. That's 2 right there. Rule 2, zeros between significant figures are significant. That 0 is between a 3 and a 4. It's between significant figures, so it also counts. So in 304, you have 3 significant figures. Our next measurement, 2.056. Well, the 2, the 5, and the 6 aren't zeros, so rule 1 says they're significant. And this 0 is in between the 2 and the 5. That means it's significant. So in this measurement, all 4 are significant. And our last one here, 2004 milliliters. The 2 and the 4 aren't zeros, so they are significant. These zeros are in between the 2 and the 4. Now keep in mind, it's not what they're directly in between. It's just asking you, is there a sig fig somewhere to the left, and is there a sig fig somewhere to the right? If there is, then any 0 between counts. That means that while the 2 and the 4 count because they're not zeros, these 2 zeros also count because they're between 2 sig figs. So all 4 of those digits are significant. Rule 3, leftmost zeros in front of non-zero digits are not significant. They are called placeholders. Now, this goes back to what I said before. Just because something's not significant doesn't mean it's not important. Placeholders in a number are important. But let's look at this. So we have 0.0078 and 0.42. How many significant figures in these measurements? Well, the first one. We know from Rule 1, the 7 and the 8 are significant. So right there, there's 2. But what about these zeros here? Well, are they between significant figures? Doesn't look it. Rule 3, leftmost zeros in front of non-zero digits. Well, these zeros are to the left of the number, and they are in front of non-zero digits. These are placeholders. They are keeping the 7 and the 8 in the thousandths and the 10,000ths place, okay? These zeros are not sig figs. They're important and have to be in the measurement, but they are not significant to the accuracy and or precision. So in this measurement, just the 7 and the 8 are sig figs. That's 2 significant figures. Our other measurement here, 0.42. The 4 and the 2 are significant because they're not zeros. This 0 here is to the left in front of non-zero digits. Just like Rule 3 says, it's a placeholder, but it's not significant. So in this measurement, there are only 2 significant figures. Rule number 4. Zeros all the way to the right after the decimal are significant. Okay. If they're all the way to the right past a decimal, they are significant. So this is the opposite direction as the other ones we were talking about. So let's take a look at this. 42.00 centimeters and 7.980 milliliters. Well, Rule 1, the 4 and the 2 here are significant. They're not zeros. These are zeros, but are they significant or not? Well, zeros all the way to the right after the decimal are significant. That means this 0, which is all the way to the right past a decimal, is significant. So the 4, the 2, and this 0 are significant. What about this one? Go back to Rule 2. Zeros in between significant figures, this 2 and this 0, are significant. That means this one is significant because it's sandwiched between 2 significant figures. That means that the 4, the 2, and both zeros are significant. That's 4 significant figures in that measurement. 7.980, the 7, the 9, and the 8 are all significant because they're not zeros. This 0 is all the way to the right, and it's past a decimal. That means it's also significant. So there's 4 sig figs in that measurement. And our last rule, Rule 5. Zeros all the way to the right before the assumed decimal are not significant. These are placeholders. So this sounds very similar to Rule 4, but it is different in that there's not a decimal in this one. So let's take a look. 23,000 kilometers and 320 grams. We look at our first measurement here. The 2 and the 3, they're not zeros. They count as sig figs, so right there's 2. These zeros here, are they significant? Well, they're all the way to the right, but is there a decimal? No. If they're all the way to the right and there is no decimal, they don't count. So that means these are not significant. They're placeholders. Still important, but not significant. So this measurement only has 2 sig figs, the 2 and the 3. 320 grams. The 3 and the 2 are significant because they're not zeros. This 0 here is to the right at the end of the number. There is no decimal, therefore it's just a placeholder, so not a significant figure. There are 2 sig figs in that measurement. So in this video, I have a little bit of counting for you to practice with. So if you want to pause this video and see if you can figure out how many significant figures are in these measurements, go ahead. I'm about to go over them right now to help you. Okay, so let's look at the first one here. 2.3000. Well, the 2 and the 3 count because they're not zeros. This 0 is all the way to the right, past the decimal, so it also counts. That means these 2 zeros sandwiched between this 3, which is a sig fig, and this 0 with a sig fig, counts. So 1, 2, 3, 4, 5 significant figures. Let's look at number 2, 300. The 3 counts because it's not a 0. These zeros are to the right, the end of the number, but look, There's no decimal place. They are not significant. They are just placeholders. So that means the only significant figure in this measurement is the 3. So it is 1 significant figure. Number 3, 805. The 8 and the 5 count. They're not zeros. This 0 also counts. Rule 2, the sandwich rule. It's between two significant figures, so it also counts. So that gives us 1, 2, 3 significant figures. Number 4, 0.002100. That's a long one. All right, let's take a look. So the 2 and the 1 definitely count because they're not zeros. These zeros to the left, remember, leftmost zeros in front of non-zero digits do not count. They're placeholders. So these zeros, not significant. What about these zeros to the right? Well, this 0 here is all the way to the right, and it is after a decimal, so it counts. That means this 0 also counts because it's sandwiched between the 1, which is sig fig, and this 0, which is a sig fig. So 1, 2, 3, 4 sig figs in that number. Okay? And the last one, 100.000. So we know that the 1 counts because it's not a 0. These zeros, well, they're all to the right, but look here. We've got a 0 at the very end. It's past a decimal, so it counts, right? That means all of these zeros count because they are sandwiched between this 1 and this 0, which is a sig fig. So there are 6 significant figures in that measurement. All right, guys, that is the end of counting significant figures in measurements. I know this stuff is a little bit tricky. We're going to take our time with it, and we're going to review it for the rest of the week. So if you're having trouble, go back through the video, watch the rules, see if you can get it. If not, don't forget to message me, email me, whatever, and I will help you as much as I can. But make sure to do that assignment that's been posted. But for Mr. Swank's Chem 1 class, I'm Mr. Swank, and hey, guys, I'll catch you tomorrow.